There are rules. Logarithms have their own rules. Now you're going to meet them. The rules of logarithms are based on the rules of exponents. So let's look at that first. If you have the same bases, like 3 to the 5th power times 3 to the 7th power, you write the base once and you add the exponents, 5 plus 7. So that gives you 3 to the 12th power. Well, this rule is similar in that if you have a log to any base, and in the argument you have two things that are multiplied, then you break that apart like this. Okay, very similar to this. Or if you have this, well, you'll see that next time, but if you have this side, log base b of a plus log base b of c, you merge those together like this. So here we have log base 6 of two things that are multiplied in the argument. So I'm going to rewrite this as log base 6 of 36 plus log base 6 of 13. And since they're just one number, you don't need to put them in parentheses. I just personally have a habit of putting them in parentheses, again, because of my exceedingly mean high school algebra teacher, who would take points off if you didn't put parentheses around it. Now there's something even more exciting we can do to this part, but you don't know about that yet. Okay, so let's go on to the next one and the next rule, which really is the other side of this rule right here. If you have log to, we're about to do this, if you have log to any base of a plus log to that same base of c, then you can merge those together, log base b of a times c. So that's what we're going to do here. We have log base t, log base t. What's t? I don't know. But we are going to be able to merge these together as 8 times 27. And just in case you're expected to multiply those together, I suppose I should call up my trusty calculator and say, hey, calculator, what is 8 times 27? 216, everybody knows that. Yeah, 216. Notice This says express as a single logarithm. So that's what we did. So these are the two sides of what's called the product rule of logarithms. Product means you multiply, or the answer you get when you multiply. The product rule. This is the product rule of exponents. And down here, let's kind of put a line around. Yeah, well, let's put a circle even around that. This is the product rule of logarithms. So is this, so I guess I should write that down. Product rule. Product rule of logarithms. Okay, feel free to interrupt me at any point, loudly and vociferously. I think they mean about the same thing, except vociferous means you've got like motivation. Okay, now, before we talk about the next rule of logarithms, let's talk about the matching rule of exponents. The power rule of exponents. And you've seen this before. Suppose you've got 3. I don't know why I'm using 3 as a base, but I am. Suppose you have 3 to the 5th power, and you decide to take the whole thing and raise it to the 7th power. Well, then your answer will be 3 raised to the 5 times 7 power, which is 35. So this will be 3 to the 35th power, which is a humongously large number. I'm not even going to see what that is. Okay, that's the power rule of exponents. When you have a power, when you have a base rather, when you have a base raised to a power and raised to a power again, you multiply the powers. Now, what about the power rule of logarithms? Okay. Suppose you have a log to any base and an argument that consists of a number raised to a power. This is what happens. You take the power and you multiply it by log base b of a. So the power, the exponent, gets moved down in front. It would be great if we had Legos. We could actually, do that. Or little letters, and we could move the C down in front. This is what we're going to do here. We've got the log to log base P of R, okay? And the argument R is, well, here, let me write this out better. This is log base P of R raised to the -9th power. I'm going to use the rule, a power rule of logarithms to bring that power, -9, down in front. So this is going to be -9 times log base P of R. And you don't need parentheses around the R now, but I was always taught to do it, so I'm going to do it, period. That is the power rule of logarithms. Power rule, airplane mode. I forget these things. Boom. Okay. Leaving on a jet plane. Any questions about the product rule? All right, or the power rule. I am going to use all of this extra room I left up here because I knew I'd be doing notes. So this actually was somewhat planned out. Let's talk more about the power rule. There are some really neat things. First, suppose you have the log of B, log to any base. All right, log base B, where B can be any base. So that includes just the word log, which is log base 10, and the ln, which is log base E. We talked about that last week. Briefly, you'll get real familiar with it. Okay, suppose I have, well, let's just do the formula. Log base B of B to the C. Then the answer is C. Is that cool? When that number and that number match, the answer is the exponent. So what else does that mean? That is, if you have log base B of B, that's it. The answer is 1. Why? Because this is b to the 1 power. Log base b of b is 1. Log base b of c is c. Log of 10 to the 3rd power is 3, because when you just write the word log, your base is 10. And the ln of e to the 5 is 5. Why? Because this is log base e. That's what ln is. Log base e of e to the 5 is going to be to the 5. And remember, e is a number that's about 2.7. So I really love the power rule. This is part of the power rule. Another way that this is taught is, suppose you have log base b, any base, of b to the c, then you bring the c down in front, c times log base b of b. Well, log base b of b is 1, because that exponent is 1. So this is c times 1, which is c. That's kind of a long roundabout way to do it. Easier to just remember this. This is cool. This is cool. A real shortcut to your work. But you can't do it unless the base number and the argument number are the same. Or I should say the base in the argument. But that's really playing with language, so let's not do that. Okay, I just wanted to show you that shortcut that you will use. I promise you'll use it. Right now, here is, down here was the power rule used in the most common way that it's used. Okay. Just stop me. Just stop me with questions. Now, express as a difference of logarithms, huh? Let's do a law of exponents first. The quotient rule of exponents. Okay, you've seen this a million times. Suppose you, I keep using the base 3. 3 to the 7th over 3 to the 5th is 3 to the 7 minus 5. So that'll be 3 to the 2. And let us not forget 3 to the 5 over 3 to the 7th equals 3 to the 5 minus 7, which is 3 to the negative 2 power, which is 1 over 3 to the positive 2 power. Well, we could even go beyond that and say, well, I know 3 to the second power is 9. And since 3 to the second power is 9, this is going to be 1/9. That's the quotient rule of exponents. We have a quotient rule for logarithms. Quotient rule of logarithms, which quite honestly people abbreviate as logs. I'll do it for you right here. This is log base R over an argument that looks like G over 9. G over 9. That's going to be log base R of G minus log base R of 9. With or without parentheses. Okay. I hear nothing, so I assume you'll yell and scream if you want me to go over anything again. Now then, well, I really need that. Well, I don't know if I need it. But here we have log base 9 of an argument, 17z. 17z is 17 times z, so we're going to use the product rule. Log base 9 of 17 plus, when you're multiplying, plus log base 9 of z. And that's all you have to do. So it's not really rocket science yet. Same thing here. Now here is ln. ln is a logarithm. It's just the natural log. This is log base e. ln, the name ln is the name log base e. That's all it is. So log base e of y times z, it's going to be the ln of y plus the ln of z. Ta-da! The product rule. Something you're going to have to kind of beat into your heads is that e is a number. It's not a variable, it's a number. Okay, now this is log of n. Where's the base? Where's the base? the base is understood to be 10 if you don't see a base written down. It's the same base as the log button on your calculator. You have log and you have ln. Pretty handy. Okay, we're going to use the power rule because we have a power in the argument. Okay, so let's write this out. Log of n to the 14th power equals 14 log n. Or n. And here's a power rule. How do I know? Well, there's a power here in the argument. This is log, and you have to write a capital A. If they write a capital A, you write a capital A. If they write a lowercase t, you write a lowercase t. So this is an argument that has t to the negative 10. Now this says to write as a product. That's because when you bring the negative 10 down in front, it multiplies log base A of t. So this is the power rule, even though they use the word product. Because this is a product when you multiply. And here's the quotient rule. Here's the quotient rule. I promise you it'll get more difficult, but let's start easy. All right, this is the quotient rule. Quotient means a quotient is the answer you get when you divide. Quotient rule. And that's log. Log what? Just log. Log base 10. Log d minus log n. That's it. And down here, ln is just a log, so ln of m minus ln of w. Now is when it starts getting a little more difficult, and then it builds to a lot more difficult. You'll be glad to know. However, we're going to keep using these three rules of logarithms. Okay, so I might as well write this down too, quotient rule. Excuse me. Okay, let's go back over it first. You've got three rules. We'll discover a few others as we go along, but these are the three biggies. The product rule, when you have two things multiplied in the argument, you add them. You take the log of each one and add. And it works either way. This becomes this, or this becomes this. So this is the product rule as well. Here's the power rule. You bring the power down in front. Quotient rule. When you have division going on in your argument, you take the log of the top minus the log of the bottom. Whereas if you have two things multiplied in the argument, you take the log of the first factor plus the log of the second factor. Now is where we put it all together. We have log here, base 10, understood. This is going to equal log of x squared plus 3x minus 10 over x squared minus 25. Okay, what is this begging for? Factoring and simplifying. So let me kind of pull this over. This will be log of plus 5 minus 2. And down here, difference of two squares. Plus 5 minus 5. The x plus 5's cancel out, leaving you with log x minus 2 over x minus 5. And that's that. Now, there's this. This is a grown-up college algebra problem. We take it in steps like peeling an onion, going from the outside to the inside. Like this. You've got a fraction in there, which means you've got division going on. And your bases are all different. Ooh, except there, but we don't skip steps. Skipping steps can be deadly. So here we go. I'm going to put parentheses around the numerator and parentheses around the denominator. My first step is going to be to write this as log base b of p squared q to the 7th minus log base b of m to the 3rd b to the 7th. I'm going to erase this equal sign. And I want to write the rule that I've used every time. How much room do I have? Oh, I've got lots of room. Okay, so I have p squared times q to the 7th. So actually, I'm going to do this. Here, I'm going to have log base b of p squared plus log base b of q to the 7th. And I'm gonna keep my brackets there for a little while. Minus log base b of m to the 3rd plus log base b of b to the 7th. Okay. I didn't write down the rules I'm using. Duh. All right, this is the quotient rule. And here we're using the product rule. Now we're going to use the power rule. Okay, there. Just have to scroll it up a little just to make it more visible. Okay, so using the power rule will give me 2 times log base b of p plus 7 times log base b of q. Minus 3 times log base b of m plus 7, well, plus 7, because when b matches b, the answer is the exponent. It's like a little magical gift there. Okay, in my next step, I'm going to distribute the minus sign. So I'll have 2 log base b of p, that's a lowercase p, isn't it? Yes, it is. P plus 7 log base b of q minus 3 log base b of m minus 7. Now I'm looking through it to see if, oh, and this, I use distribution here. Yeah, okay, I use the power rule to bring down the 2's and the 3's. And yeah, the 7. Okay, now I'm just using distribution to get rid of the brackets and to distribute the minus sign. And now I'm looking to see if anything else needs to happen. And it does not. This is the answer. Two log base b of p, 2 times log base b of p, plus 7 times log base b of q, minus 3 times log base b of m, minus 7. Okay. Now this is not written that well, and it's the reason that I have a real problem with the way this book does not put the argument in parentheses. So I'm going to rewrite this. This is log base c of the cube root of x to the 5th over y to the 3rd times c to the 7th. Okay, and we're going to go one step at a time. Sounds like a 12-step group. We could do math in a 12-step format, because it would definitely be one step at a time. Log base c. Now watch what I do here. Remember, there's another way to write roots. X to the 5th over y to the 3rd, z to the 7th, to the 1/3 power. Now I'm going to use the power rule. And this equal sign just refers to, well, this should equal the step above it. But I'm just moving, I'm using the different rules. I'm going to move 1/3 down in front and I'm going to have 1/3 times log base c of x to the 5th over y to the 3rd c to the 7th. All right, I'm going to have to use the quotient rule, but this 1/3 is multiplied by all of it. So I'm going to have to put brackets around that just to keep it together and to keep the 1/3 separate until the end when we'll distribute it into the whole thing. All right, so the power rule, we're going to use the quotient rule now. Okay, and again, this equals means equals what's above it. Keep moving it over. Okay, 1/3 bracket log base c of x to the 5th minus log base c of y to the 3rd z to the 7th, close my brackets. That's what I've got now. Uh-oh. I don't have all that much room, do I? Okay, well, everybody hope. Okay, now I'm going to use the product rule. Now I could move that 5 down in front, but I prefer to not mix steps, if that makes sense. So log base c of x to the 5th. Oh, wow. Minus. Okay. All right. I need to put brackets again. Brackets. Log base c of y to the 3rd plus log base c of z to the 7th bracket. Now, watch what I do. You probably haven't seen this since pre-algebra. When you studied nested parentheses, we changed the shapes just to make it more clear what we're doing. So let me move this over. This is 1/3 times all of this. We have log base c of x to the 5th minus, now this stuff is together. This stuff has just had the product rule applied to it. So there's a plus sign there, but that minus sign is going to act on all of it. So we have to be very careful. See, here it's actually important because this 1/3 is waiting to act on all of it, but that's the very last thing that we need to do. Okay, so now I'm going to distribute. So that'll be 1/3 log base c of x to the 5th minus log base c. Now I'm distributing of y to the third minus times plus is minus log base c of z to the seventh. Now we really don't need braces anymore. I could go back to brackets, and I probably will in the end. Well, not in the end, but now, maybe. Okay, now I am going to use the power rule to bring these powers, exponents down. All right, let's see if we can fit it in. Power rule. We'll have 1/3. I'm going to go back to brackets. 5 times log base c of x minus 3 times log base c of y minus 7 times log base c of z. And finally, the last step. Almost the last step anyway, distribute. We're going to distribute the 1/3. 1/3 is going to be multiplied into all 3 of these terms. So we're going to have 1/3 times 5 log base c of x minus 1/3 times 3 log base c of y minus 1/3 times 7 log base c of z. And now all I have to do is multiply these numbers together. Multiply. That is, what I meant by that is 1/3 times 5 is 5/3. Log base c of x minus 1/3 times 3 is 1. So this is just going to be log base c of y minus 1/3 times 7 is 7/3 times log base c of z. And that is your answer. And we barely had enough room to fit it in. That's what you'd put in the answer box. So you can tell here, you're going to be using your subscript keys, you're going to be using your superscript keys, you're going to be using everything. Okay, let's see how much we have left. Yes, important, important, okay. Well, you can certainly do this, but it's ln, so let's just do this. We'll have the ln of 8 minus the ln of x to the 7th y. So that'll be the ln of 8 minus, we're going to need parentheses here. The ln of x to the 7th plus the ln of y. Oh, I only have one exponent. Oh, I forgot a 7. There's a 7 here. You're kidding me. There's the 7 right there. All right, well, ln 8 minus, I'm going to bring the 7 down inside the parentheses. So I'll have 7 times 7 ln x plus ln y. And then I'll distribute. 7 times 7 is 49. Minus 49 ln x minus ln y. Now let me see. Okay, ln 8 minus the ln, oops, minus 7, that's 7, that I wanted to leave off. No, 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 no. No, I'm glad I caught that. Let's go back. That's what happens when I speed up. I get so careless. So will you. Don't speed up. Now slowly and carefully. This is the denominator. So and this is the numerator. The ln of 8 minus the ln of 7 times x to the 7th times y. Okay, now, the ln of 8 minus bracket the ln of 7 plus the ln of x to the 7th plus the ln of y. That's why I'm using the brackets. See, this becomes a plus and a plus. You've got 3 separate terms in there. This minus is going to apply to all of them. So this is going to be the ln of 8 minus bracket the ln of 7 plus, bring down the 7, 7 times the ln of x plus the ln of y. All right, now I distribute the minus sign now. Minus the ln of 7 minus 7 times the ln of x minus the ln of y. Yes, double checking, double checking. All right. Now we were told to take this apart in terms of sums and differences. So I'm not going to put anything back together. So equals, 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 right there. Okay. Now, before we do that, Here in these last two, whoa, I made that big, didn't I? In these last two, we're being asked to express as a single logarithm and, if possible, simplify. So here we have two separate terms and we're being asked to squish these back together. You have to go in steps. The first thing you have to do is you can't squish that together. Not yet. It has to be log of argument plus log of argument, and then you squish them together. I say plus because there's a plus there. I have to move this back into the power position and this back into the power position, or exponent if you prefer. That's gotta be my first step. I'm working backwards now. Log, and that's log base 10, A to the 1/2 plus log B to the 3rd. Now, well, we could do this first. Log of A to the 1/2 times B to the 3rd. Equals log. Anything to the 1/2 power is a square root. The square root of A times B to the 3rd. And now, a fine point here. Anything outside the radical, here it's a square root radical, but anything outside the radical usually goes in front of the radical. So it's not, there isn't the danger of thinking it's underneath the square root. So I'm going to rewrite this as log B to the 3rd power times the square root of A. Boom. Think about going backwards. Now here too. Before I try putting these together, I've got to do the following. Got to change this to the ln of x to the 6th minus the ln of x to the 1/4 power, right? The 4th root is the 1/4 power. And take this 4 and move that back up. Now remember your power rule of exponents. When you have a base raised to a power again, you multiply the powers. So this is going to be the ln of x to the 6th minus the ln of x to the 1/4 times 4. And that's 1. So this is going to be the ln of x to the 6th minus, you're kidding, the ln of x. Well, now we're going to use the quotient rule, and that's going to give us, I need to skip some room here, the ln of x to the 6th over x, which is going to be what? X to the 5th. This is x to the 1 now. So you're going to have the ln of x to the 6 minus 1. That's the quotient rule of exponents, which will give you the ln of x to the 5th. Okay, anything else? All right, we've got one more to do and we can have all your homework done. I think all your homework done. This one. There you go, you have log. Remember, that's a square root. It's 1/2 power. This is going to be, all right, express in terms of sums and differences. So they want you to expand this. Log of b to the 7th times c to the 1/2 power, which is 1/2 times log of b to the 7th times c. Okay, you're going to have to use the product rule in here. Let's put our brackets. Equals 1/2 log b to the 7th plus log c. Almost done. This is a much shorter one than that harder one. We're going to have 1/2 7 log b plus log c. And that's what? Never mind. Now I distribute the 1/2. Oh dear. And the 1/2. So we're going to have 1/2 times 7, that's 7 over 2, times log b, plus 1/2 times log c. Yep. Yep. Okay. The best thing, I know it's a pain, but the best thing to do, I believe, is to take a long time doing this and write this down one rule at a time as you do it. Keep your notes out beside you, your flashcards preferably. It's the product rule. Here I brought down the 7, so that's the quotient rule. And then distribution. It's the best way to learn it, to do it over and over and over. Okay? Okay. Well, we're done. This is what we were going to do today. Tomorrow it's more complicated. Tomorrow and Thursday, we're going to be using these rules to solve exponential equations and logarithmic equations. So stay tough. We're almost done. Yes, we are.
Thank you. Have a good day.
You too.
Have a nice day.
You too. Bye, everybody.
Bye.